y'all get it yet? I'm sorry? 33? Yeah, about 33. So that's A, right? Not A squared? Okay. I see a couple of people agreeing, so 33. Let me go ahead. I'm not going to actually, I'm going to plug things in, but I'm not going to do the computation. This is what we're doing, though. Cosine of 91 degrees. There we go. So that's what we actually had to do, right, on the calculator. And you get A is 33. Yes? Can I proceed? What do we do once we have A? You can do law of sines, right? You can do law of sines again. I want to show you something, though. There's another option, right? There's another option where you don't have to do law of sines. And the thing that's good about this second option is that, you know, in the law of sines, we keep on running to that thing with the circle and having two possible things to look at. This other option will eliminate this from being an issue, all right? So what I'm going to do right now is I want you to see, just take a pause here on this. I want you to see, we're trying to solve for, we need capital B and capital C still, right? I want you to look at the formula that has, the law of cosines formula that has capital B in it. See the second one? Okay, watch, I'm just going to write it down. It's B squared equals A squared plus C squared minus 2A times C times cosine of capital B, right? That's the formula, the second formula, right? Now look, we want to know what capital B is, right? Look at this equation. Aside from the capital B, the only other things here are little a, little b, and little c, right? But I know little a, little b, and little c now, don't I? I know all of them. So what I'm going to do is I'm not going to plug in. I could right now. I could plug in little b, little a, little c. I could plug them all in. Instead, what I'm going to do is I'm going to actually solve this formula for cosine of b. Just watch first, all right? So what I'm going to do first is I'm going to move these two terms to the other side of the equation. So to move that over, I need to subtract it. Move that over, subtract it. So it's going to look like this. B squared minus A squared minus C squared equals negative 2 AC cosine B. Right? Algebraically, I just move those two terms to the other side, right? Now, I'm going to try and get this by itself. I'm going to divide this on both sides. Negative 2AC. I'm going to divide both sides by negative 2AC. That cancels everything over here. The only thing left on the right is cosine of B. Over here, I'm going to do something tricky, all right? Pay attention to what I'm about to do. Do you see this negative out here? Yeah. Negatives on fractions, if they're sitting out on the bottom like this, I can move it to the top, can't I? That's the way that's the way negatives work. Hey, that's the way negatives work on fractions. If I have like 1 over negative 4, that's the same as negative 1 over 4, but then that's the same as negative 1 over positive 4. So the negative can float, right? It can be on the bottom or on the top or out front. I'm going to take this negative and I'm going to move it up to the top and then distribute it through. Why? Because when I do this, it's going to look like a formula that you would see in a book, all right? So imagine that negative is now going to become positive. I put the negative up here and distribute through. It will make this negative and these two positive, won't it? Yep. Okay, so here's what it would look like. I'm going to write it in a nicer, cleaner manner. You see? That's negative b squared now, so I put it at the back. That's positive a squared, so I put it at the front. That's positive c squared, so I put it in front. All over 2ac, but now positive, right? Last step. I want to know what capital B is, right? How do we kill cosine? With the inverse. So I'm going to take the inverse cosine on both sides of the equation. I take inverse cosine of a squared plus c squared minus b squared all over 2ac, that equals capital B. And the good news here is that when you do inverse cosine, what's the domain restriction for inverse cosine? 0 to pi, right? So there's not two different answers we're going to have to think about. It's going to give me the correct answer between 0 and pi, 0 and 180 degrees. And the angle B has to be between 0 and 100. Right? Remember, when we use the inverse cosine, the reason we get two answers over here is because when we use our calculator throws away these two quadrants, right? So my calculator doesn't realize there could be a second answer. But with inverse cosine, you no longer have that issue. Okay? So whatever we get for B is the correct answer. We don't have to check it. Okay? So that's nice, right? Now this is a formula that you see in some textbooks. It's not on our formula sheets. All right? So I don't mind if you add this to your formula sheets. You can add that, all right? Do y'all see how I got it, though? You see how I did it? All right, so please feel free to add that one. While we're at it, there should be two other formulas just like this, shouldn't there? I mean, this is how you get capital B. What would the formula for capital A look like? But still, it's still cosine, but these things change, right? So where did this come from? A, C, B. That came from up here, right? A, C, B. Any guesses on what this one is going to be for us if we're solving for A?
So A was cosine inverse, which is B squared plus C squared minus A squared over 2 times B times
B squared plus, what did you say?
C squared,
C squared minus
minus
A squared
over 2 BC.
BC. There you go. That's the formula for A, capital A. And then the formula for capital C is going to be A squared plus B squared minus C squared over AB. Those are the three formulas for capital A, capital B, and capital C. You could figure out all of these formulas the same way I did this one, right? You could do that on your own. I'm not going to go through that for each one. So using that, let's find capital B, okay? Let's find capital B. So to find capital B, I'm going to use this formula right here. Capital B is equal to cosine inverse of, all right, I need to do A squared, right? So that's 33 squared plus C, which is 28 squared, minus B, which is 17, and then squared. Then all over 2 times A, which is 33, times C, which is 28. Any questions on where I got any of those numbers? Now this, you're going to need to make sure you type all that into your calculator properly. I'm not going to do the inverse cosine yet. I'm just going to figure out what all this is on my calculator. Let's see if you get the same thing I get. So I'll do this a little slower. I'm going to get the top first. The top I get 1584, and on the bottom get 1848. Now I could figure out what this is as a decimal right now, right? I could take those two answers. So now I get B is cosine inverse of 0.8571. I'm just going to go with that. Now on my calculator, cosine inverse of that answer, About 31 degrees. Yes? Question?
I got 6/7.
31 degrees. You got 6/7 where?
6/7 when I plugged in just what was inside of the parentheses.
You got 657 here?
Like 6/7.
Oh, does it reduce to that? It might reduce.
I don't know if it makes any difference in my.
Oops. Well, I got to make sure. Let me just check. 1584 at the bottom. Yeah, it is 6/7. That is 6/7.
But it doesn't make a difference.
It doesn't make a difference because you're going to take tangent inverse of it. All right, we got 31 degrees, yes? Once we know what B is, 31. See, isn't that nice? We don't have to check two different possibilities. All right, now it's an ugly formula, but you know. And then once we know that's 31, then we can get the other one by using the fact that they add up to be 180, right? So what's that last one going to be? 58. And just to make sure we didn't screw anything up, let's just make sure that the biggest angle matches the biggest side, smallest angle, smallest side. So biggest angle is 91, that's the biggest side. Smallest angle is 31, that's the smallest side. Everything looks good. Got it? All right. How about this one? Number 7. Number 7. What has been given to you? Yeah, all the sides, right? Little a, little b, little c. I've given you no angles, have I? Right? No angles have been provided. Capital A, don't know. Capital B, don't know. Capital C, don't know. Little a, 14. Little b, 9. Little c, 6. Right? Is it possible to find the angles?
Yes.
Do we have formula to find capital A? I just erased it, didn't I? I just erased it. We have formula for finding capital A. We have formula for finding capital B. We have a formula for finding capital C, right? Really, I only need to find 2 of these angles, right? Or actually, I could just get 1 and then go law of sines, right? Imagine that I knew capital A, right? If I knew capital A, I'd have capital A, little a, and then I could go figure out the rest with law of sines. But I am personally going to avoid the law of sines because of that discrepancy we have when we do the inverse, that it gives us 2 possible things. So I'm just going to use law of cosines to get these 2, and then I'll get the third by using the fact they add up to be 180. Just safer that way. All right, let's go. Capital A is the inverse cosine of, it's the way I remember it is that it's the other 2 sides I don't have, B and C, or the other 2 letters, b squared plus c squared, then take away the a squared, then divide that by 2bc. I don't know. You have it written down, right? So you don't have to look it up. I mean, you don't have to memorize it. You can just look it up. So capital A here is cosine inverse of 9 squared plus 6 squared minus 14 squared all over 2 times 9 times 6. Will somebody give me what's inside of here before you do cosine inverse? Will someone give that to me?
137.
0.37?
137. Oh, inside.
Yeah, inside all of this right here. 0.731. Anybody else get that?
I got a negative.
Oh, yeah.
You got,
Sorry.
oh, negative? Okay, negative. All right, now, negative 0.731. Turns out it's not, it wouldn't even matter if it was positive or negative because cosine is an even function. So when you plug in positive, you get the same as negative, but technically it is a negative in there. All right, now do the inverse cosine of that on your calculator and give me the angle. 137.01 degrees. All right, we know capital A. You all tell me, how do you want to go get B? Do you want to go get capital B using the formula for capital B that's sitting right here? Do the same thing? Or do you want to do a law of sines to get capital B? Just go right into this? Yeah, just stick with this? Okay. All right. So plug in capital in that, plug everything in that capital B formula. I'll write it out. Capital B is equal to cosine inverse of, let's see, a squared plus c squared minus b squared over 2ac is the formula. So capital B is cosine inverse of, let's see here, 14 squared plus 6 squared minus 9 squared all over 2 times 14 times 6. Who's got what's inside there? Anyone got it yet? 0.8988? Is that what I heard? Is that what I heard? Yeah, okay. And then do cosine inverse of that, and what do you have? I forgot that I had the answers here. I guess I could have looked at this a long time ago. Oh, no, never mind. It doesn't. Okay, what do y'all get? 25.99? 26, I guess, whatever. So that's B, 25.99 degrees. And then you know that they all add up to be 180, right? So now you can get the last one without using a formula. $17. Just check real quick that biggest angle goes with biggest side. Yes? Does? Smallest angle, smallest side? We're good to go. Do y'all like this more than identities and all that other stuff?
Yes.
Yes? Yeah, this is a lot more mechanical, right?
Yeah.
All right, I have another problem for you to consider. It's not on it's not on those sheets. All right, so I'm making this one up myself. How about this one? What if I tell you that A is 30 degrees? Let's let this angle here be 80 degrees, and this angle here be 70 degrees. Let's make that one B. Let's make that one capital C. Can we solve the triangle? I'm hearing no. Capital A, B, C, little a, little b, little c. All right. We know all the angles, right? Capital A is 30 degrees. Capital B is 70 degrees. Capital C is 80 degrees, right? Let's first think about law of sines, right? If I wanted to figure out what A was, I would have to use either A over sine A equals B over sine B, or I'd have to use C over sine C, right? That's the law of sines. I'm solving for this, right? Which means I would need to have big A, little b in big B, right? I would need all those to solve. And the problem is I don't have little b, right? And if I tried to use a over sine A with this one, again, I don't have little c, right? So I can't solve using law of sines. How about law of cosines? What do I need to find A? I need little b, little c, and capital A, right? I need little b, little c, and capital A. I only have capital A, right? And same thing with little b. I can't solve for little b because then I need to know little a and little c. You see, I don't have enough information. And that shouldn't surprise you because all I'm doing is giving you a triangle that has fixed angles. You can imagine like zooming in and zooming out on this triangle. You can make this, there's an infinite number of triangles that would be that shape. Right? Do y'all get that? So this is one situation we can't handle. Nobody can. There's no like secret formula that you ever learn because there's an infinite number of triangles that could look like that. So if you get nothing but angles, you can't tell me, all right? You can't tell me. Which I won't ever ask you a problem with all angles, but I want you to understand that what we have right now is very powerful, but there still is certain scenarios that we can't handle, and that's the one. Can we handle all other scenarios? Can we? Let's think about it. All right, think about this. If this was A, B, C, little a, little c, little b. What if I only gave you one side and two angles? Could you do it? Yes? If I gave you one side and two angles, then you would know all three angles, wouldn't you? So if you had one side and all three angles, what could you use? Law of sines or cosines? Sines, right? If you had one side and all the angles, you use law of sines. What if I gave you one angle and two sides?
Cosine.
Law of cosines?
Well,
As long as
one side, as long as you have capital A and capital A and lowercase a, then you can use law.
yeah, so in order to use law of cosines, I would need the two sides and the angle between them, right? So single angle and two sides, I should be able to get this side, right? And once I have that side, I should be able to get the rest with law of sines. So what about this one then? Do you think we could handle this? What if I gave you, I'm going to circle what I'm giving you. What if I gave you this side, this angle, that side? Could you do it? See, notice I didn't give you the side and the angle and the two sides here. I gave you the angle across and I gave you a different side, right? You could do this?
Yes.
How?
Law of sines.
Sines, law of sines. So basically, the moral of the story is this. We can solve any triangle now as long as it's not this scenario. If it's just angles, nobody's going to be able to solve that. But any other combination, we can solve the triangle completely. All right? Which is good, right? We want to be able to solve triangles. All right, how are we doing here? 157. I know that some of you, when you were learning about, some of you have seen this before. You're learning this in high school or wherever, and they teach you, okay, angle, side, angle, we do this. Side, angle, angle, right? Side, side, angle. You all remember hearing that in high school or something? No? I never teach it that way because, I don't know, instead of memorizing like, if you have side, side, this, or this, do this, I like to just list out what I have and then just understand the laws and use them as needed. All right? To me, that's a better way to understand it. That's just personal opinion, though. All right, let's do a problem here. Almost there, hold on. All right. I'm going to draw a picture, all right? You know how my pictures are, so here's what we've got. We've got the ground, and we've got a slight hill. Ooh, that's a pretty big hill, all right? So imagine if the ground were to continue to go straight, that's what it would be, all right? And then what I have here is I'm going to tell you that this is a 20-degree slope right there, all right? So this is the ground, and the ground, there's a little hill, all right? And then what I have right here where this ground starts to go up, I have a pole, all right, or let's say a tower, okay? It's like a cell tower, cell phone tower, all right? And I'm going to tell you that the height of that tower is 500 feet, okay? What's wrong? Does that seem too tall? Yeah.
No,
Okay.
no,
You're
just thought of something else.
something else? All right. All right, y'all see the tower right there? You see the ground? You see the hill? Okay, here's what I want to do. 100 feet away from the bottom of this, 100 feet away, I'm going to put an anchor point, and I'm going to attach a guide wire that's going to go up. That's supposed to be straight. Okay. I'm going to attach a guide wire that's going to anchor to the top to keep this pole from falling or swaying in the wind, all right? And then on the other side, halfway up, I'm going to attach another anchor like this, and that is also going to be 100 feet this way. My question is, how long are these wires going to need to be? So let's call this one W1 for wire 1 and W2 for wire 2. And my question is, how long are those wires? Do you understand the geometry of this? Like, do you see it? Right, because this tower is like, it can sway and move, so we're going to put these wires to anchor them in so it doesn't move around. And I just need to know how long those wires are. So how long are W1 and W2? And did y'all catch what I said? W1, I want it halfway up. Okay, so that means from here to here is what? 250. All right. I'm giving y'all time to draw and think. Would y'all like me to color the ground green? I don't have green. Sorry, I thought I did. It's just a green cap. South Texas, so we'll put brown. Right? Just burnt grass. Hey, easy. Easy. Burnt grass? What are you talking about? Who said that? Oh, now you get it. Now you get it.
Yeah.
I just keep thinking of that one stripper in Houston that fell through the feet off her stripper pole.
This is being recorded.
Oh, this is being recorded. That's right. You're talking about burnt grass and stripper poles. What the hell is going on?
This happened like right after COVID during the pandemic, and there was a stripper in Houston, and she was on a 30-foot pole, and she fell off.
Not a 30-foot stripper pole.
It was a 30-foot stripper pole.
What the hell?
Pole,
So it wasn't like
I
a
was
pole.
just imagining like a stripper pole.
Oh. Hmm. Okay. All right, so now you've had some time to think about this and other things, apparently. How do you want, let's go after W1. What do you think? You ready for W2? Let's start with W1 just to go in order. What are your thoughts on W1?
Is that a right angle?
Is this a right angle? Well, y'all have to convince yourself or convince me. I don't know. Is it a right angle?
Yes.
You're assuming that this pole is vertical, which I think we can assume. And the ground is flat, so Yeah, I think we can assume that this is a 90-degree angle, right? Which would mean that this little triangle is a right triangle, not oblique. And so everything we learned before law of sines and cosines would apply to that triangle, right? Yes? So let's see, what do we know? Let's draw this triangle right here. Let's draw that one. It would look like this, this, this. This is W1. Do you know any of the other sides?
Oh,
250 is here, good. And do you know this side? What is it, 100? You have two sides of a right triangle, right? Can you get the third side if you have two sides?
Yeah.
Yes, using what?
Law of cosines?
You don't need to work that hard because it's a right triangle.
Oh,
Pythagorean, right? A squared plus b squared is c squared. You see? We don't need to work harder than that. We have these. Hey, by the way, check this out, everyone. Check this out. This might blow you away. Maybe not, probably not.
I'm already blown away.
Look at this right here. If we have, let me draw it this way. Let's say we have this arbitrary triangle like this, right? And we're trying to solve for, let's say we're trying to solve for little b here. That's capital B, this is little a, this is little c. Y'all with me? Law of cosines would be perfect for this if I was trying to solve for this, right? Because I would need to know what that is, and what that is, right? Imagine that B is 90 degrees. Okay? Go to the law of cosines for this. You know what? Hold on. Let me draw it a little different. I should have drawn it this way. Hold on. This will be more impressive, I think. Yeah. Shit, it doesn't matter. Let's just leave it. This is B. This is capital B. Okay? So imagine that B is 90 degrees.